Well, today we would like to welcome Dr. Eleni Pliakoni, who is an associate professor of urban food production and post-harvest handling at Kansas State University at the Olathe campus, and Dr. Manreet Bhullar, who is a research assistant professor in the Department of Horticulture and Natural Resources in the Food Science Institute here at Kansas State University. The project that they were working on was funded by the Global Food Systems Seed Grant from 2021. And the title of this project is evaluating the effect of innovative food labeling technology on produce quality, safety, and consumer acceptability. Dr. Pliakoni?
Thank you so much for having us here. As we already talked about, we're gonna discuss our seed grant of 2021. And I am going to cover the quality part of this project, and Dr. Manreet Bhullar is going to cover the safety and sensory part. So I'm starting with a little bit of background. This idea came by try to understand a better way, or try to find a better way of labeling fresh produce, because right now we are using the PLU stickers that help us get some information about the produce, like price, where they're coming from, and that is really important to get that information. However, those stickers are providing some environmental contamination because of the plastic and the glue. And maybe it's not the best way of labeling our produce. Also, another role of the stickers is the traceability part. Lately, we have seen a lot of fresh produce recalls for foodborne illnesses. So it's important to be able to trace back the recalls. So those stickers are there to identify where the produce are coming from. However, sometimes they're easily removed. So we were trying to figure out a better way of labeling our produce. And this is the idea that we came up utilizing a laser printer to actually label the product on the put the label on the product, so it cannot be easily removed. This is not a very novel idea. Like, people have used that in the past to actually label the product on the actual surface of the produce. However, our novelty comes from the fact that we are using a QR code for that. And some of the benefits of having a permanent marking on the product is that you cannot remove it. So you cannot ever lose the ability to trace back. And it's more environmental sustainable, since we're not using plastic or glue, and of course helps with improving the traceability. One of the things that I didn't mention in the previous slides is like this environmental contaminations is kind of very important, since European Union, starting with France, has already banned the utilization of those stickers. So if we want to move forward with exporting in EU, we will need to find another more sustainable solution. So in our project, we are utilizing this laser printer that you see in the picture. It's not a printer that is specifically developed for printing produce, as an art printer. However, before we purchase, we connect with the company and we figured out that they could actually print on a produce surface. So we select that printer, and then now that we have this great idea that we can print on the produce surface, we need to figure out if that has any effect on the quality of the produce post-harvest, the microbial safety, and also if it's acceptable for the consumers. So after a lot of preliminary experiments, we identify 3 produce that we tested with this seed grant, and it was apple, cucumbers, and green bell pepper. And I'm moving forward to the materials and methods that are related with quality. And we use this laser, we use two patterns, a QR code and a text code, and also we use edible waxing on top of the pattern, because we very fast identified that there was a lot of water loss at the print. So we want to make sure that we are reducing the water loss and be able to maintain the readability of the QR code and the text code. So here you can see how our printer is working. It just takes 12 seconds to do the QR code. It's very fast. And here is like the whole materials and methods that are including the quality and the safety. I'm gonna cover the quality part. So as I said already, we use QR code with wax coding and text code with also wax coding and like the control. And we evaluate for water loss, visual quality by using a scale from 0 to 5, and the readability of the code after specific days of shelf life. And for the apples, we use 16 days at 4 Celsius, and for the green peppers and cucumbers, 8 days at 4 Celsius. And moving forward to our results, here you can see the percentage of weight loss in apples. And as you can see, our QR code had the highest percentage of water loss. But if we concentrate at the percent that we actually lose, this is very small. And basically it does not affect the marketability of the product. So we did see a little bit more loss at our QR code, but that does not affect the marketability of our apples. Moving forward to cucumbers and to bell peppers, we also saw a little bit more water loss for our QR and text codes at the cucumbers. However, as you can see here, the percent of water loss was slightly increased from the control. And again, it does not affect the marketability of the product. On the bell pepper, basically the water loss was the same. We didn't have like differences between the control and our treatments. Here you can see the visual quality ratings, which is from 1 to 5. And we didn't see any difference between the different days of storage. So what we see in this table is that our control and treatments for the apple didn't change a lot for the visual quality. We didn't have like significant differences between the control and the treatments, but we did have some significant differences between the two different labels, the QR code and the text, which the text was slightly better in terms of visual quality, but as you can see, the numbers are super close. In cucumbers, we didn't have any changes in the visual quality from the control and our treatments. And in bell pepper, it seems like the text code was a little bit better, but as you can see, the numbers is very, very similar. And as I told you, the scale was with 5 being the best visual quality. So you can see all our numbers are really close to 5 up here. The last result I'm going to discuss regarding the quality is the code readability. So we actually evaluate how readable was the codes that we made after 16 days for apples, 8 days for cucumber and bell pepper. And as you can see, apples behave better than cucumbers and bell peppers. We have like 92% readability after 16 days. When in cucumbers, we had like 77.8. That means 14 of our that means that we could read 14 from our 18 total cucumbers, and it was kind of low for bell peppers, and that was mainly because we have a lot of water loss, and like the pepper was like shriveling around the area of the coat, so we were not able to have good results here. And now I'm gonna move the presentation to Dr. Bhullar to continue.
The second part of the study was to test the microbial safety. We tested 3 different treatments previously, QR code, text code, and a control. We didn't find any significant difference in the post-harvest quality characteristics. So the next part was to test if those treatments, such as application of QR code or the text code, have any impact on the microbial susceptibility or the contamination of the product. So for the safety assessment, we used 5 different treatments. QR code with the wax, because that's how typically most of the fresh produce is sold or marketed, with a wax layer on it. And the second was without the wax. That was just another treatment, like what would happen to microbial contamination if there was no wax on that engraved QR code surface. Similarly, with text code, it was with a wax and without a wax, and the last one was a control. So all these treated or printed fresh produce commodities, they were inoculated with E. coli, a rifampicin resistant E. coli inoculum. So if there is any microbial background microbial population on the produce, that doesn't interfere with our results. So we have the antibiotic resistant strain as a tagged strain to quantify for the bacterial behavior after the treatment. So 3 codes were sampled from the produce surface from 1 product and 1 sample, and these were put into a centrifuge tube with a buffer to harvest all the attached cells to the QR code, printed QR code on the produce, and then cells were enumerated, or the sample volume was enumerated on TSA plates with a 80 microgram per milliliter rifampicin. So only rifampicin resistant E. coli grows, and none of the background microbial flora grows on it. So for the results, and this graph, we have log CFU per centimeter square. That's the microbial population on the different treated commodities. And on the x-axis, we have 3 different fresh produce commodities: apple, green bell pepper, and cucumber. And if we look at the apple results, we have the first blue bar for the non-treated control. The next one is QR code with wax. Third is QR code with, the second is without wax. The third is with wax. The yellow is a text code without wax, and the green one is text with a wax. So if we see, the control is no different than the QR code with and without the wax. However, the text coded had higher microbial contamination as compared to the control and the QR code. And we see similar trend in green bell pepper and cucumber as well, where there was no significant difference between the control and the QR code treatments, but significant difference exists between text code and QR code and text and the control, which could be due to several factors that we hypothesized, that text code had more surface area engraved on the surface of the product that provided more space for higher microbial attachment as compared to the QR code. Since there was no significant difference between the control and the QR code microbial attachment, it proves that there's a potential for QR code to be established as a commercial technology for produce labeling. The study 3 was about the consumer acceptability, where we wanted to know the perceptions of consumers when they see a QR coded product in the market. Since text coded had higher microbial contamination, we did not test it for consumer analysis or consumer acceptability. So the treatments for this study were QR code label and the plastic label, that's the PLU sticker, and the non-treated control. There were 75 participants between the ages of 16 to 64 who did this study, and there were open-ended and closed-ended questions for them. They were allowed 20 minutes to respond to these questions, and the parameters that we tested were overall liking for the labels, the purchase intent, the concerns about different types of label, concept liking. Do they like the concept of PLU stickers application or the QR code with all the benefits, and the concept of purchase intent, their preference for either one of them, and their recommendation to their friends about buying any type of these two labeled products. The responses were compared based on before and after providing the information about laser labeling. So we have the data from the first set. That's where the consumers do not know what is this technology or what is the print. And then we shared information about this is how laser technology works. This is a non-chemical approach. It's a permanent mark. And then their response changed a little bit. So the results show us that for the overall liking, the sticker label had higher number. So there was higher interest among consumers for the overall liking parameter. For label liking, again, the sticker label was higher than the QR code, which is pretty much understood because it's a new novel technology and consumers didn't know what this is, what the technology is. The purchase intent, that's how willing they are to purchase a sticker or a QR coded product, and sticker code had higher, significantly different number score here. The label concern, the higher is the number, the higher is the concern. So there was a bigger concern for QR code, again, based on no background information on how this technology works. The concept liking was similar, sticker label and a QR code label. The concept for purchase intent was still different. Sticker label had higher than the QR code. Overall preference, comparing sticker with QR code, there was slightly higher in QR code. Still, we saw differences here where sticker label had the higher score, but for the overall preference, we did see a slightly different percentage number here. Recommendation to others to buy produce with a sticker label was higher than the QR code. And if we, when we tested the overall responses before sharing information with them, there was increased concern about the QR code label. And there was a significant difference between the control, the sticker, and the QR code. However, after we shared information about the technology, the overall concern or the ranking for the three different product types was similar. There was no statistical difference. And this emphasizes more on the education and outreach part of it, and to bring that consumer awareness about the technology, what it is all about, and what benefits it brings to our food supply chain. So in conclusions, laser labeling technology did not significantly impact the quality and the safety of the product. However, there were few concerns about the consumer acceptability. There were concerns such as if this is an ink on the product, do we have to wash it off, or do we have to cut off that part of the product to eat it? So these were some of the questions, the information that we did not address in our questionnaire. So there were challenges in addressing those questions. However, moving forward, more effort needs to be made towards the education part of it to bring awareness among the consumers that QR code as a safe technology to put on labeling for fresh produce commodities. The wax application did not change the susceptibility. That's what we found from the microbiology study data. The QR code readability was the greatest in the apples. However, for the green bell pepper, it was the lowest. Different products interact differently with different wax coatings. So more research is needed to enhance the readability of the wax coating onto different items. As I previously mentioned, all the consumers liked the concept of laser labeling, but there were a few concerns about the purchase intent. So more information or more efforts are needed to improve the consumer's perception about it, about this technology. And overall, we believe that laser technology has the potential to be used in commercial application with the benefits of improving traceability and protecting the safety of the public. So the next steps are we have applied for a patent, which is under review with the KSU Innovation Partners. The project was recently nominated for the Moore Inventor Fellows Program, and it's already approved by the VPR office. We also plan to submit SBIR funding in the near future. And the next research plan is going to focus on developing a pilot scale laser labeling system where we can print QR codes at a faster speed and multiple products can be printed at the same time to meet the commercial speed of labeling in the produce industry, and optimize the application of laser technology to engrave the QR codes on how to engrave or readability on the food surfaces, because it did not work on all produce commodities. So more research is needed to specifically design the laser technology parameters to engrave on such surfaces. And we want to thank Global Food System Seed Grant Program for funding this idea and all the support from the Office of Vice President of Research at K-State. Durga Khadka is a MS student who worked on this project. She worked really hard and did an excellent job in completing the project on time. And other collaborators on the team include Dr. Martin Talavera, who led the consumer analysis study. Dr. Kerry Ward and Dr. London Wadike will help us in the extension component of it and sharing the information from the study to the Kansas growers and fresh produce processors about how this technology can be brought to the commercial scale. And Dr. Logan Britton helped us with the economic analysis, which we are still working on. And we have our contact information here for Dr. Eleni Pliakoni and me. If you have any questions, please feel free to reach out to us. Thank you.